This video is about the nature of science. What is it that science is all about? Well, a famous physicist, Richard Feynman, says the test of all knowledge is experiment. Or another quote of his is, observation, reason, and experiment make up what we call the scientific method. There is a method, a formal method for exploring science. And one of the things about it is you have to be able to test whatever it is that you're talking about. So here are the steps of the scientific method. Problem, the observation or research into that problem. Then you formulate a hypothesis. You take a guess as to what the answer is. You have to be able to conduct an experiment for it to be science. If you can't, then it's not science. It doesn't mean it's not valid, it's just not science. So if you come up with a theory but it's untestable, or when I say theory, I should say hypothesis, when you come up with a hypothesis and it's untestable, then it's not science now. Possibly in the future, we'll have technology to test your idea and then it will become science, but until then, it's not. After you conduct the experiment, you collect and analyze your results, and then you make a conclusion. The conclusion is how you're going to communicate your results to the world. Other scientists need to see how you did your stuff, so they can do it and try to prove you wrong. Not in a mean way, but that's a very powerful tenet of science, that when you come up with something that other people are going to try to test it and try to prove it wrong. If they can't, it doesn't necessarily mean you're right, it just means that it hasn't been proven wrong yet. And so let's go with that because that's the best we've got right now. Science does this all the time. And sometimes we come to the limitations of our technology. In astronomy right now, there's a lot of exoplanet hunting going on. When Kepler spacecraft was launched, it was capable of doing things that no spacecraft in previous generations were capable of doing. And we found, since the 1990s, thousands of planets. Prior to that, we hadn't had much success detecting any planets. So as technology improves, as our ability to gather information improves, we're able to prove and understand our universe in more and deeper, richer ways. As you can see, these steps of the scientific method have been around for many years, and so you can either call it the problem or the question. You can have observations and have that to satisfy what your problem is, or sometimes the observation comes first and then the problem. You can do research into what is known about that, but hypothesis, experiment, conclusion, that is our scientific method. And we go through that over and over and over again. And a lot of times one experiment will lead to new questions, which will allow us to research that area as well. That is how science is done. Science isn't rigid. Once we come up with something, we can always change it if new evidence comes to light. And science needs to be testable, or it's not science. Well, that's all for now. I hope to see you in class.